Before we talk about inverse trig functions, I want to review inverse functions in general. Recall that for a function f, every element in the domain corresponds to one and only one element in the range. This means that if a point AB lies on the graph of f, then there is no other point on the graph that has A as the first coordinate. However, there may be other points having B as the second coordinate, since the definition of function allows range elements to be used more than once. So with a regular function, x values don't repeat, although y values can repeat. If a function is defined so that each range element is also only used once, then we call it a one-to-one function. So here's our formal definition of one-to-one function. A function f of x is one-to-one if for x1 and x2 in the domain of f, if x1 does not equal x2, then f of x1 will not equal f of x2. So basically, if the two x values are different, then the two y values are going to be different as well. Equivalently, if f of x1 is not equal to f of x2, then x1 won't be equal to x2. So that is, if the y values are different, the x values will be different as well. No two inputs map to the same output. The graph of a one-to-one function passes both the vertical line test and the horizontal line test. If a function is one-to-one, then the function maps every x to one and only one y, and no two x values map to the same y value. This implies there is a one-to-one correspondence between the input and the output of that one-to-one function, where the input are our domain values and the output are our range values. A real-life example of a one-to-one function are people and social security numbers. Each person has one social security number, and no two people have the same social security number. So there is a one-to-one correspondence. Because of this one-to-one correspondence, we could type in a person's name and get their social security number, or type in their social security number and come up with their name. So we could go this direction, say that's our function f of x, or we could go this other direction. If a function is one-to-one, right, it's going to be possible to map the output back to the input, which is what we're doing here if we type in a social security number and get somebody's name. This mapping would also be a one-to-one function, and this mapping is specifically called the inverse function. And we denote inverse with the little like -1 as an exponent. Defining inverse function, we have a couple here, depending on our context. The function that maps the output back to the input of a function f is called the inverse function and is denoted f inverse of x. The inverse function of a one-to-one function f is defined as f inverse of x equals the set y comma x such that x comma y is an element of our original function f. What this is saying here is that the inverse function can be obtained by simply interchanging the x and y coordinates in ordered pairs. That's just our fancy set builder notation of saying that. Inverse functions have a couple properties. Our first property, which is the one I think we use the most, says the domain of an inverse function is the range of the original function, and the range of that inverse function is the domain of the original function. This again is just reinforcing the fact that x and y change roles when we switch from a function to its inverse function. Property number 2 says that if you perform function composition with a function and its inverse, you'll always get x. And we can kind of see that in our diagram. Right? If we're starting here with people, this is going to be our x value because it's our input. Right? So if we first apply our function f and then f inverse, we end up where we started, which was with x values. Similarly, we could start with social security numbers being the input value, so that's the x. We could apply f inverse followed by f, and we end up where we started, which was with an x value. So that's what that property number 2 is saying for us. Property number 3 says the graphs of inverse functions are symmetric with respect to the line y equals x, and I have that illustrated to the right. The process of finding an inverse function given a function is you first need to verify that the given function f of x is a one-to-one function because only one-to-one functions are eligible to have an inverse. Then we're going to take it out of function notation by letting y be equal to f of x. We'll interchange x and y and then solve for y. Lastly, putting it back into function notation by replacing the y with our f inverse of x notation. We often restrict the domain of a function that is not one-to-one to make it one-to-one without changing the range. For example, I have f of x equals x squared graphed to the side. This is not a one-to-one function with its normal domain of all real numbers. It fails the horizontal line test. But if we were to restrict the domain to 0 to infinity, we'd only be looking at this right portion of the graph. That right portion has a domain of 0 to infinity, and it's maintained the range of 0 to infinity as well. That's the range if we looked at the whole thing. If we just consider this one section of the parabola, it's one-to-one, and we can talk about the inverse. In the remainder of this section and in future videos, we're going to develop our inverse circular functions, our inverse trig functions, using this same idea of restricting the domain to a one-to-one section.